Hello everyone. Today let's solve the problem reposts. Right. So we'll be solving the problem reposts. This was asked in Codeforces VK Cup 2015. So this was asked in the qualification round 1. This was asked in qualification round 1. This one, right? I hope this part is completely clear, man. So let's go with the question. Let's go with the question. So you can just go through the question. It is very easier to understand, right? So this is the question basically. So they have mentioned the input and output part as well. So I can just go through the question. It is very easy to understand. So let me summarize this one for you so that it will be easier for us to solve the problem, right? So let's go with the first question here. Just give me a second, 1 second. So yeah, first thing here is there is a guy called Polycarp, right? This one I'm speaking of. There is a guy called Polycarp. He shared a joke. Others reposted it in a chain. So Polycarp, PC, I'll go with PC. Polycarp shared a joke and it was shared by others within a chain. It was shared by others within the chain, right? Within the chain, right? Others reposted it in a chain, so we are given n reposts in the form of a reposted b. We are given n reposts here, many others reposted, right? We are given n reposts in the form of a reposted b. A reposted b, we will be given in the form of a reposted b, right? So again, Polycarp shared a joke, others reposted it in a chain. We are given n reposts in the form of a reposted b. This one I'm speaking of, right? I hope this part is clear, man. All names are case sensitive. All names are case sensitive means here we have to go with the we have to convert all the things to all the letters to lowercase. So they have strictly mentioned all names are case sensitive, right? So here we have to find the maximum depth of repose starting from the Polycarp. So they themselves have mentioned that we have to find the maximum depth of the reposts starting from the Polycarp. So basically this is a tree question. They are asking to find the maximum depth, means we have to go with the DFS. We have got the hint directly in the question itself, right? So quite obviously they have given here all the names are case sensitive. We have to convert all the letters to lowercase. Then they have asked us to find the maximum depth of reposts starting from the Polycarp. So here there has to be Polycarp somewhere, right? I'll just come here, this one, see here, tourist reposted Polycarp. So here we have five inputs, right? So starting from the Polycarp, what we need to do, we have to find the maximum depth of reposts starting from the Polycarp, right? So we have to find the maximum depth here, right? This one, starting from the Polycarp, basically this one, starting from the Polycarp. So that is the length of the longest repost chain. So this itself, we have to find the maximum depth of repost sharing from starting from Polycarp. That itself is the length of the longest repost chain. So we have to return the longest repost chain. In simple words, we have to calculate the maximum depth. For that, we'll be making use of the this one, DFS. We have to calculate maximum depth of repost, that is starting from the Polycarp. So for that one, we'll be making use of the DFS, and we have to return the length of the longest repost chain. We have to return the length of the longest repost chain. Nothing but here in this case we have been given 6 here, right? So we have been given 6 here. So here and let's come to the examples part itself. I hope the question part is completely clear, man. Again, I'll just read it out loud. Just try to understand this one. Polycarp has shared a joke, others reposted it in a chain. We saw this one. We discussed this one. We are given n posts in the form of a reposted b. We have been given n reposts in the form of a reposted b, basically, right? So all the names are case sensitive, means we have to convert all the names to lower letter or the this one, lowercase or the uppercase. So let's go with the lowercase. We have to find the maximum depth of the repost starting from the Polycarp. For this one, we'll be making use of the DFS. Basically, this is the main part. What we need to find, we need to find the maximum depth of the repost, that is starting from the Polycarp. That is nothing but the length of the longest repost chain, right? So we will be making use of the DFS again. So we will be making use of the DFS. So just keep this in mind. We will be making use of the DFS, right? So I hope this part is completely clear. Question part is completely clear. Let's come to the examples here. We have five inputs, right? You can clearly see here 5 lines, 3, 4, 5. Um, so we have to, the output is 6 here. For this one, the maximum depth of the repost that is starting from the polycarp is 6, or in simple terms, the length of the longest repost chain is 6 here. Right, same thing here. We have 6 inputs. You can count the lines 1, 2, 3, 4, 5, 6. So the output, the here the longest repost chain is 2. And let's come to the final one here. Let's come to the final one. This one and this one, only one, this one input we have. So this one, the output is 2 here. So let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. I'll do one thing. I'll consider the first example here. They have given here this one, right? So I'll just consider this input for the approach. So let's discuss how we got this output, along with what is the this thing, data structure we'll be making use of. Basically we'll be going with the DFS, as I've said, right? So what is the data structure we'll be making use of, and other stuff, right? So I'll just show for this example. I insist you to try out with the other inputs. I insist you to either try out with this one or this one, so that you understand the approach better. You can go with your intuition rather than mine, right? I'll just try to understand, I'll just show this one for the approach, example one, by considering example one for the approach. So you can just try it out in the same way, or you can just try it out in the similar way that I show with the these inputs, either this one and this one, right? So you can do that. So you'll understand the this one question better, and your way of writing the code may differ, right? So you can write code, even your code might be even simpler than mine. So you might write the code better than mine. So that's what. So let's carry on with the, let's move on with the approach part here. Let's move on with the approach part here. Just give me a second, 1 second. Yeah, let's move on with the approach part. So approach followed by the complexity, approach followed by the complexities, and then let's write the code. First, let's, as usual, let's discuss the approach first. So here we have considered the same first example that they have given in the question. We have considered the same first example that they have given in the question. So here, tourist reposted polycarp, Peter reposted tourist. This one, W is this one, this name, basically some random name they have given. Reposted Peter, SDYA. This one also reposted this one name, this one reposted SDYA. So this is fine. The output that we need to get here is 6 for the first input, or the first example, basically, right? So we are considering the same first example that they have given in the question. So 5 inputs we have. So the output that we need to get here is 6, right? So here in this case, let's go with the step-by-step explanation, man. We have to convert all the names to lower cases. This we have discussed in the question itself. So they have said that this one, all the names are case sensitive. In the question they have said that all the names are case sensitive, right? So we will be going with the, we'll be converting all the names to lowercase for the case insensitive mapping. So the second thing is, we have to build the graph tree. We have to build the graph tree. So I'll not be showing the tree. So in the previous problem we have already discussed the same thing, man. So you can just go through the previous problem, how to build the tree, basically how to build the tree, and you have to get the adjacency list of it. You have to get the, by you have to build the tree and get the adjacency list of it. That's it. Yeah, right. So the first step, when I say we have to build a graph tree, means we have to consider the edges from source and to reposted by, to reposted by, right? So I hope this part is completely clear. The second one, you will understand this one very clearly when we write the code, or you can just draw the tree and you can just check as well. You can just build the tree, draw the tree, and you can just you can just get the adjacency list of it, right? So I hope this part is clear, man. Let's go with the next step here. So here we have polycarp. Polycarp here, this one, let me come here. Polycarp tourist. So then it will be Peta. Then we come here. Yeah. Polycarp tourist Peta. This one, WJ something they have given here, right? So this one. Then finally, this is one, 4 we have, right? Then this one followed by SDYA or SADYA or SDYA they have given. So we'll be considering this one. SDYA, this one. Finally, we have 5 here. Polycarp tourist depth first search we are going with, right? So this is question A. Basically it will be very easy, right? So the first question that was asked in VK Cup in the elimination round one. So in the round one, basically, not the elimination round one. So this one, 1 2 3 4 5 we have. Finally what we'll do, we'll go with this one, VEPIFANOV, right? VEPA, this one, where this guy. So this guy, right? So the final one, it will go like this. The final one, reposted SDYA, right? So this will be Polycarp followed by tourist followed by PETA followed by this WJM guy followed by SDYA followed by this one BPIFANO, this guy basically. So the we are calculating the depth by making use of the DFS. We will be calculating the depth. Depth you can clearly see here itself, right? We just have to implement the same thing in the form of code. Means we have to perform DFS. You have to know the DFS part. That's it. You have to know the DFS part. Means we have to know how to implement the DFS, right? So this is it. Next, the output that we got here is 6. Here itself we can just guess, but yeah, let's go with the step-by-step explanation here. Polycarp, tourist, PETA, this guy, SDYA, this is this one, and Webifan or something. Yeah, this is length 6. This forms a chain of 6 users. So we have the chain of 6 users, right? So we will make use of the DFS from Polycarp from here. We will be making use of the DFS from Polycarp, tracking the depth. Quite obviously, to track the depth, we'll be going with the DFS. It's better to go with the DFS itself, right? So for any this one, what do we call? For any tree problem, you can either solve it with the DFS or the BFS. We know this, right? So whenever that is focused on the depth, it is better to go with the DFS itself, right? So we will be making use of the DFS from Polycarp, tracking the depth. So final answer, the maximum depth in DFS would be 6. The maximum depth in DFS would be 6. So we will return 6 as output. We will be returning 6 as output. Again, I'm telling, we will be returning 6 as output, right? So 6 is the output that we got, which is equivalent to the output that they have given for the example one, right? Which is equivalent to the output that they have given for the example one. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's discuss the complexities part quickly, right? So what would be the time complexity? So the time complexity would be big of n here. So why it will be big of n here, right? So n per test case, because we are going with the each repost that is visited exactly once during the DFS. Means here each repost is visited once during the DFS. Each repost is visited exactly once. Each repost is visited exactly once, right? Each repost is visited exactly once during the DFS, right? What would be the space complexity? So overall time complexity would be big of n, quite obviously, because we are visiting the each repost exactly once, right? So overall time complexity would be quite obviously big of n. So what would be the space complexity? The space complexity would be big of n as well, because for the adjacency, we I insisted you to draw the tree and get the adjacency list, right? So we will be getting the adjacency list. That is the reason I said we'll be making use of the adjacency list, right? So for the memory, we'll be going with the adjacency list. We have to store the values somewhere, right? Of the adjacency list. So we will be going with the adjacency list. Again, memory. And the recursion stack as well. So the depth of the recursion stack, we all know. The depth of the recursion stack is nothing but big of n itself, right? So overall space complexity would be big of n as well. Overall space complexity would be big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n. Big of n, right? So I hope the approach part and complexities part are completely clear. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Let's start writing the code. So let's start writing the code. I'll just come to the compiler here. So first we'll be making use of the fast input and the fast output. So let's import the input output package here. So I'll just go with java dot input output dot star. So we'll be making use of the utilities as well. So I'll just go with here java dot util dot star. So this is fine. So next, let's go with a class name here. So this one will be class main. So this is fine within the main class. we will be making use of the graph here. So we'll be going with the graph to store the to store who reposted from whom. I'm speaking of from to the list of users who reposted from them, right? So we'll be making use of the graph to store who reposted from whom. This one we have already seen this one in the question. They have strictly mentioned, right? Someone reposted from someone, right? So in the input also they have given first thing itself is a tourist reposted Polycarp, right? So we are going with a graph to store who reposted from whom. That one I spoke of the example one that we considered in the first input. They said that this one tourist reposted Polycarp, right? So here in this case again I'm stressing on it. We'll be making use of the graph to store the who reposted from whom. So I'll just go with here static map. So this will be string. So I'll just go with the string here. This one will be list. So this will be string. So let me close this one here. Mm, yeah, this is fine. String. So let me consider the variable name graph, and this one will be making use of the hash map. We'll be making use of the hash map here. We are creating the hash map. Again, in simple terms, what we are doing, we are making use of the graph to store who reposted from whom. Hash map will be very handy, right? It comes with the this one key value pair. So here hash map will be very handy. So the next step is we have to track the maximum depth of the repost chain. So we'll be making use of the this one DFS for that. So some variable has to act as counter here, right? So here in this case, let me go with static int max depth and assign this one to 1 and assign this one to 1. So this is fine. So let's go with the main here. Let's go with main here. So let me delete this one. So let me delete this one entirely. So within the main. So let's make use of the input output exception as well, man, or else we'll get the error. So I'll just go with input output exception. So this is fine. Exception. So this is fine. So within the main, what we'll do, let's go with the fast input. Suppose for the fast input, we'll be going with the buffered reader. Buffered reader. So I'll just go with br variable name. So this will be new buffered reader. New. This will be input stream reader of system.in. So this is fine. For the output, fast output, we'll be going with a print writer, or for now let's ignore that one, and after this one making use of the buffered reader, the variable name br here, we have to read the number of reposts. We have to read the number of reposts. Number of reposts has to be in the form of integer, so let me do one thing. Let me assign n to integer dot parse int. So this will be buffered reader dot read line of this is fine. So let's come to the for loop here. Let's move on with the for loop here. Means let's move on with the iteration part. So here we have to read each this one, what do we call uh, iteration, right? So I mean sorry, repost, right? So here in this case it will be int I equals 0, I less than, we consider the variable n, a number of reposts, nothing but the number of reposts here. So this one will be I plus plus. This is fine. Within the for loop, what we'll do, we'll read the line and split A reposted B. Nothing but it has to be case sensitive as well, right? So that's what they have given in the question. We have to read the line and split A reposted B. Nothing but it has to be case sensitive as well. So here in this case, I'll just go with a string. I'll consider variable parts here. This will be br dot read line. So this one, let's go with two lowercase, right? So here two lowercase dot split here, dot split. So this one I'll just leave the space. I'll just go with reposted. This is fine. This is fine, I guess. So after this step, we have to go to the person from whom it is reposted, right? So we have to display or go to the person from whom this one whom the post is reposted, right? So also we have to go with the person who reposted. These two things, we have to go to the person from whom it is reposted. First, let's write the code for that. So I'll just go with here string from and to will be making use of here in simple terms the variable names. So this one will be parts of one. We have to go to the person who reposted. So for that one, we'll be making use of 2 here. 2, this one equals parts of 0. This is fine. So let me come out of this one entirely. Not come out of this one. So let's move on with the further things. Basically, we have to add the edge from to 2. From to 2, we have to add the edge from to 2 here. This one fine. So why this is showing on this one? This is fine. Next, let's do one thing. We have to add the edge, right, from to 2. How can we write that one in the form of code? So let me go with here graph dot put here if absent. So let's consider from here, this one will be new array list, this is fine, new array list. So this will be graph dot get this will be from. So let's make use of the operation add. This will be 2. This will be 2. So this is it for the code. We have just successfully added the edge, nothing but from to 2. This one, these two lines, right? So this is fine. After doing that, so accordingly with the approach, what we need to do now, we have to start the DFS from polycarp. So initial poster will be polycarp, right? So we have to consider the polycarp as the initial poster with the depth 1. So that they have given in the question. So what shall we do? Let's go with the DFS. Before making use of the DFS here within the main function, let's do one thing. Let's perform the DFS or let's make use of the helper function DFS. Let's write the code there and then make use of the that helper function within the main function, right? So I'll just go with the static void DFS here. This would be string user int depth. This is fine. So within this method, what we'll do, we have to update the maximum depth at each step. So I'll just consider this one max depth variable and let me assign this one to math.max. We have to update the maximum depth at each step, right? So I'll just go with here. So not this one. Let me copy this one here and let's go with depth. Let's go with depth. This is fine. So if no one reposted from this user, we have to return. We just have to return nothing, right? So if no one reposted from this particular user, then we don't have to return anything. So I can write in this way. So here, if not of graph dot, so as we are making use of the hash map. So this we can just go with the contains key here. Contains key of user means if no one reposted from the user, then we don't have to return anything. I'll just give return. We're not returning anything here, right? So next step, if you remember, I said we'll be going with the recursion, right? So we will recurse for each follower who reposted from this particular user, right? So we already discussed this one. We'll be going with the DFS with recursion. And also in the space complexity, I said that we'll be making use of the for the memory, we'll be making use of the adjacency list, so that we have to calculate the adjacency list. I insisted you to draw the graph and calculate the adjacency list, right? So I didn't show that in the previous problem. I have showed that one. If you want to know how to get the adjacency list, so I can just google it. If you don't know how to what is adjacency list, right? So you can just google it, you'll get it. A very easy concept, right? So you can just do that, right? In the previous problem also, we have while building the graph, I have shown by drawing the graph and getting the adjacency list from it, right? So you can just check that one as well. The problem number 28 I'm speaking of, right? So I hope this part is clear. So now we have to recurse for each follower who reposted from this user. Let's go with the simple for loop here. This will be string follower, yeah, follower. This one will be graph dot get of user, graph dot get of user. So this one within the for loop, what we have to do, let's increase the depth for the next level. Let's increase the depth for the next level. So this one will be follower comma depth plus 1. So I hope this part is clear, man. I hope this part is completely clear, man. So we are just in this line, don't get confused, in the line number 29 we are just increasing the depth for the next level. We are just increasing the depth for the next level, right? So this is fine. Next, what we are doing now, let's continue from where we have left in the main function. So here we have to start the DFS from polycarp, right? So I have said this one, we have to start the DFS from polycarp, nothing but the initial poster. Polycarp itself himself is the initial poster that they have given in the question. We have to start the DFS from the polycarp, nothing but the initial poster, with the depth equals 1 initially. So here let me go with DFS. We are making use of this helper function here, right? So DFS, yeah, this will be polycarp, and this is ARP. This is fine. Polycarp, comma 1. This is fine. So the final step is we have to output the maximum depth. Nothing but I'll just give here system.println. So this, let's pass the maximum depth. Let's pass the maximum depth. So this is it for the code. This is it for the code. So before checking with the input, I'll just copy paste the signature starter template. So this part you can just ignore it. So yeah, you can just ignore this one. Just concentrate on the this one. What do you call the logical part? So we are done with this pure DFS, right? Pure DFS with recursion. Basically, that's what we are doing for this particular problem. So let me come here. Let's consider this one. We have to get the output 6 for this one. Let's check whether this works or not. So we have static map, class map. So we have to go with a capital M, I guess here. So this has to work. So let me do one thing. Let me make this one capital M. Let me run this one. Now this error has to go. Yeah, this is fine. Cannot find the symbol. Maximum depth. Max depth. Oh, I have misspelled here line number 21. This has to be X max depth. So let me run this one. This error has to go. Yeah, now we are getting the output 6. Yeah, correct output, right? So we are getting the correct output. Let's check for the other inputs. So let me copy this one. So we have to get the output 2 here. Let's check whether this works or not. So here you can clearly see we are getting the output 2. Let's check with the final input. For this one also we have to get the output 2. So let me delete this one. So yeah, let me run this one. We are getting the output 2, right? So we are getting the output 2. So here whatever the code that we have written works absolutely correct for the inputs or the examples that they have given for the question, right? Within the question basically. So let me copy this one and let me paste it over here. So this is problem A, right? Yeah, this is problem A. Let me select A here and let me hit the submit button. So now this has to work. Let's see. This has to work. Let's see. So you can clearly see here running on test by. Yeah, this got accepted. In the tooltip it is showing accepted right here. So here, yeah, it is showing accepted. Means whatever the code that we have written works for all the test cases. Means it works absolutely fine, right? So I hope the solution part is completely clear along with the approach and complexities, right? For now, this is it. Thanks for watching, guys.